work on solving systems of equations. So we're going to do this today, tomorrow, Monday, all right? So we're going to be solving systems today using our graphs. We might look at the tables, but we're probably just going to look at graphing them. And then tomorrow we're going to do solving by systems by substitution and elimination. And then Monday we're going to look at inequalities. So graphing, inequalities where we're going to shade again, but it's going to be where we're shading two regions to get a complete solution. So a system of equations is a set of two or more equations containing two or more variables. Right? So you might have x and y. There are systems with three equations and three variables. And we're not going to cover them, but I will make those available for those of you who are interested. Then you can do those for extra credit. Okay? A linear system involves just linear equations. When we do chapter 10 in Algebra C, we'll look at ones that are non-linear and how they work. And we're actually going to be using Desmos when we go to there. Right? So recall a line is an infinite set of points that are solutions to a linear equation. The solution of systems of equations is the set of all points that satisfy that system. So if we have two lines, linear equations, then either there's three situations that can happen. There's either one point where they intersect, or they don't intersect at all, or the two lines could actually represent the same line, and we have an infinite number of solutions. On the graph of a system of two equations, the solution is the set of points where the lines intersect. All right, so we're looking for a specific point. So first we're just going to look at verifying, does this point satisfy the solution? Now you just in the warm-up, you check to see if a point satisfied one equation. Well, what we're going to do is we're going to check to see if it satisfies both. And for it to be a solution to the system of equations, then that point has to satisfy both of them, right? And that shows that if it does satisfy both of them, then that's the point where the two lines cross or where they intersect, right? So we're going to put in 1, 3 for x and y in both. And if it doesn't work in one, I don't have to do the other one, all right? Because if it doesn't work in one, I know it's not a solution, so I'm done. So we'll substitute 1 for x and 3 for y in both equations. Right? And so you should show that they are both simplified to be the same. So when I put in 1 for x and 3 for y in the first equation, it works. All right, they're both sides become -8. All right, so that one's good. So we're good so far. So we check it with the other one. All right, so those both are equal to 9. All right, so the point 1, 3 is a solution to that system. All right. So you check them both. If it works in both, then it's a solution to the system. If either one of them doesn't work, then it's not a solution to that system. All right, so you do letter B. All right. Okay. So -4 1/2 doesn't work. All right. So now let's look at graphing. All right. So we're going to solve systems by using this as graphs and tables. We're going to completely focus on graphs. So the first thing you have to do, well, it's nothing. You don't have to do it this way. When you're graphing them, you can do it two different ways. All right. You can use the intercept method if you want, or you can use the slope-intercept method. Now, we're going to focus on the slope-intercept method because the next question we're doing, the next example we got to work on, we're going to actually classify systems, whether they're by how many solutions there are. And so the best way to do that is to be able to have them in slope-intercept form. So the first thing that we want to do is we want to get these in slope-intercept form so that we can graph them using the slope and the y-intercept. And when you're graphing these, you have to use graph paper because they have to be perfectly accurate so you can see where the two lines intersect, because that's the goal that we're trying to find, is where they intersect. All right. So we're going to solve for y first of all. All right, so we subtract 2x. And we want them in slope-intercept form, so we're always going to put them so that the x and then the y. Right. Divide by -3. So y equals, I have -2 divided by -3, positive 2/3 x, and 3 divided by -3, -1. All right. So there's our first line. Right. The second one, y plus 2 equals x. We just need to subtract 2 from both sides of that one, so y equals x minus 2. All right, so we're going to graph both of these lines using our graph paper because we need to see where they intersect. So I know some of you don't like to use graph paper, all right, but this is an instance where you need it because you have to be accurate with your graphs. All right? Now you can always, once you get your answer, check it just like we did with in example 1. But very important that you use your graph paper so you have completely accurate graphs. All right? Okay, so all right, go ahead, I'll give you a moment to set it up. All right, so when we graph the lines, the first one, y-intercept -1, the slope of 2/3. So up 2/3. All right, we draw that line. Then our second line has a y-intercept of -2 and a slope of 1, so up 1/1. Right. So when we draw this line, then we need to make sure it's accurate, so I'm going to actually add a couple more points so and I can see where I'm going. So this works out nicely. We can actually see where the two lines intersect because I actually marked that point. Right? So my solution to this equation then is the point. Right? So I've got this point here where both those lines intersect. So my answer is the point 3, 1. All right? So when you write these answers, you actually are going to write them as that point, right, where they intersect. All right, so we write them in slope-intercept form, or you can use the intercepts. It doesn't matter, okay? But easier using the slope-intercept form when it comes to the next problem anyway. So, but how you graph these is up to you where that comes from. All right, so go ahead and do B. And then we'll look at them with our calculator. All right. Okay, did everybody get that? All right, now let's go to our calculator. All right, so take out your calculator, and let's go back up here to the first one, example A. All right, and put one of these in Y1 and the other one in Y2. All right. Put one in Y1 and the other one in Y2. Doesn't matter, it's up to you which one goes where. All right, so you have them written on your paper, so I'm going to go ahead and go to my graph. All right, so Y equals 2/3 x minus 1. Now you can either use the fraction bar, or you need to make sure that your x is in the numerator though, okay? So y equals, or I can just use parentheses, right? 2/3 x minus 1 and x minus 2. All right, so there's my two lines. All right, now we graph them. Oops, so I need to hit zoom 6, so I'm in that standard viewing window. All right, and here it shows where the two lines intersect. Now, we could just look to see what it is, all right, and guess, all right, but your calculator will find those things for you, all right. We showed this the other day, so if I go to second trace, all right, second trace, and we want to find the intersection point, which is number 5. All right, so we choose that. Then it asks us for the first curve. All right, so what's the first line we're working with, which is always your y1. Hit enter. All right, so second curve, that's y2. So I'll hit enter. All right, and then your guess. If there's only one place where they intersect, it'll go there. So you don't need to do anything with it when it says guess, except for just hit enter, and it should give you those numbers. X equals 3, y equals 1. All right, where they intersect. Okay. And if I was to go to my table, look to see where x equals 3, then both of them should have 1 there. Okay. All right, so you go ahead and do the second one, all right, with your calculator and see if you get the same answer that we did of -3, -5. All right, so put them when they're in slope-intercept form, put them in your y equals. And then we're going to go to second trace for intersection. All right, second trace for intersection. So you do the second one, make sure you get the right answer. And then we're going to do one of these. I'm going to rewrite one of these down here. Okay, so graphing them by hand, which you're going to have to do. All right, so you can show me those graphs, and then you can use your calculator, all right, to find those answers also, to check them, to make sure that they are the correct answer that you have. And you can even take it from using it on your calculator, all right, take it off your calculator, put it on the graph screen, on the graph itself. All right, but here's a nice way to find them with our calculator. Now, if you're at home, you don't have a calculator, what do I have access to? You got Desmos, all right? And so with Desmos, I could type in, so like in B where it's got x plus y equals 8, 2x minus y equals 4, I could just type those in just like they are, and Desmos is going to give me the answer. Okay? So that actually works well too. Okay? All right, classifying systems of equations. We classify them as either being consistent, right, a consistent system, or an inconsistent system. Right? If they are consistent, they have at least one solution. If they're inconsistent, then they have no solutions. Independent systems have different slopes, and dependent systems have equal slopes and equal y-intercepts. All right. So we have consistent, inconsistent, independent, and dependent. And the ones that are independent and dependent are the ones that are consistent. All right. So they have to be consistent to be either independent or dependent. All right. If they're independent, they have exactly one solution. If they're dependent, then they have an infinitely many solutions, which basically means they're the same line, right? So if there's one solution, the two lines are going to cross, which means that their slopes are going to be different. If they have infinitely many solutions, which means they're consistent and dependent, they have the same slope, same y-intercept. Right. And if they're inconsistent, then they have no solution because those lines are parallel. So if they have one solution, like the ones we've just done, consistent and independent, they intersect because they have different slopes. Right? Every line that has a different slope, every two lines have different slopes, they're going to intersect. If they're consistent and dependent, when you simplify them, your y-equals are going to be exactly the same. And if they're inconsistent, then they're going to have the same slope, but a different y-intercept because they're parallel. Right? So parallel lines are inconsistent, they have no solution. Lines that have the same slope, same y-intercept are consistent and dependent. Different slopes, then they're consistent and independent. Right? So all we need to do then to be able to classify is we just need to find the slope and the y-intercept for the two equations. And once we see if the slope is different, we're good. Okay, we're done. All right? But if the slopes are the same, then we need to check the y-intercepts. If the y-intercepts are the same also, then there's an infinite many solutions. If the y-intercepts are different, they're parallel, and we have no solution. Okay? So go ahead and take both of these, A and B, and solve them both for y first of all. Okay? So get them in slope-intercept form to start with. Go ahead and do them both. Okay? So after getting them in slope-intercept form, all right, we check the slopes and the y-intercept. Okay? So for letter A, both slopes are 1/2. Okay? So that means we either have an infinite number of solutions or no solution. So then we check our y-intercepts. All right? Those are both -3. So this is these are the same lines. All right? So this means that these are consistent and dependent, and there's an infinite number of solutions. Consistent and dependent infinite number of solutions. All right, letter B, they have the same y-intercepts. All right, they're same slopes, but they have a different y-intercept. That means they are what kind of lines? What kind of lines are they? Same slope. They are parallel, right? Okay, these are parallel lines, railroad tracks. All right, when's the railroad tracks, when do those two parts of a railroad track intersect? Okay, hopefully never. If they do, we have problems, right? Okay, so these are inconsistent and there is no solution. Okay. So parallel lines, inconsistent, no solution. Same line, called consistent and dependent, there's an infinite number of solutions. Okay, all right, last one. All right, application problem. City Park Golf Course charges $20 to rent golf clubs plus $55 per hour for the golf cart rental. Sea Vista Golf Course charges $35 to rent the clubs plus $45 per hour to rent a cart. For what number of hours is the cost of the rental clubs and a cart the same for each course? So we gotta look at the key elements and write the equations for the lines that represent each of them. So we've got City Park Golf Course. Right? They charge $20 to rent golf clubs and $55 per hour for the golf cart rental. All right. Now, what value can change, the 20 or the 55? Okay, the 55, okay? So the 55 is what's going with our variable. Okay? So we have our equation for City Park is going to be y equals, and whether you put the slope or y-intercept first is up to you, but I'll put the slope first, all right? 55x plus 20. All right, because this is 55 per hour, so let's change it. Now, if you want to use different letters, if you want to use H for hours, you can do that too. All right, so and when we get done, we're going to have to explain what our answer means then. Okay, all right, then we've got C Vista, all right, which charges $35 to rent the clubs and $45 per hour to rent the carts. Right. So y equals 45 is the number that's changing, so 45x plus 35. Right? And so we need to find, they want to know for what number of hours is the cost of renting the clubs and a cart the same for each course. Right? So they want us to find out where these two lines intersect. Right? Where they intersect. And we're going to use what, Emma? The calculator to do this one, okay? All right, now, can we graph it on paper and do it? Certainly we can, all right? We know the slopes, we know the y-intercepts, we can. But we're going to look at it with our calculator. So go ahead and type it in your calculator. Put the first one in y1, the second one in y2, all right? Becomes a little bit more challenging with the calculator, but it's not too bad. All right? It actually should go faster than if you're using just paper to do it. All right? All right, so when I graph it on my calculator, all right, here's the things you need to think about, all right? Sabrina, what are the y-intercepts? Okay, 20 and 35, okay? Those are the first two numbers you need to think about, is the y-intercepts, okay? And so on my graph then, I'm starting at, one of them starts at 20 on the y-axis, the other one starts at 35 on the y-axis, okay? All right. Now, the slopes, all right, they're positive, which means the lines are going up as they go to the right, correct? Okay. So, when I look at my window, all right, and I look at my y values on my window, my y min, my y max. Y min, in this case, you don't have to worry so much about, but it's the y max. Right now, my y max is 10. Well, the one of them starts at 20, so that 10 isn't going to help me, is it? Right? I need to go higher than that, okay? So the second one's at 35, all right? So I have to go higher than that. But every hour, they're adding either $45 or $55, so it's going up pretty fast then. All right? So you have to take that into consideration, all right, when you graph this. Now, if I just graph it right now, all right, all I see is two lines that are close together and don't help me much. All right? So I need to change my y max, okay? But is there somewhere else I can go that would actually help me do that faster? Okay, there is. Go to the table. The table will actually help us. And we can actually find the answer probably with our table even. All right? All right, so we can see these numbers going up pretty fast. Did I type them in right? All right, so so after looking at our table, all right, so let's go up to 1,000 on our y-axis. All right, so y max, I'm going to make it 1,000. All right, which means I'm going to I'll go by 50s on my scale. Okay, and graph it. All right, I guess I missed it. Okay, so I can see where these two lines intersect here. Okay, all right, so second trace, number 5, and 1 for the first curve, again for the second curve, and my guess. And so, there's the problem right there. Okay, all right, so after an hour and a half, okay, they're the same, and I should have seen that, all right, because when I look at my table, what happens? Okay, y1 is smaller than y2 at 20, 75, all right? So 20, 35, 75, 80, but then it changes, doesn't it, from 130 to 125. So the answer is going to be between 1 and 2 because the y1 changes from being smaller than y2 to being bigger than y2, all right? Those are things you're looking for. So I could go back here and change my window, make it a little more realistic here, and just make it, we'll go 300 just to make it smaller. Oops. All right, that's better. Okay, so what we're doing then, all right, checking to see if points work. All right? Graphing to find where the two lines intersect on our graph paper with a ruler, making it easy that way. Okay, checking it with our calculator. All right, classifying systems. All right, so we'll find the slope and the y-intercept. Check to see how they relate. All right, then solving systems of equations with applications. All right, so let me find this answer again here. All right, but then we still got to write down what does the answer mean. All right. So I found this answer. Question is, what does it mean? All right. So, X stands for what in this case? All right, the hours that we are renting the clubs, okay, or renting the cart, okay. So, if we rent a cart for 1.5 hours, it will cost the same all right, $102.50 at both clubs. All right, so I've included both my X value and my Y value in that answer then, in that sentence.